Okay, this is the second of 3 videos that I'm going to be making about square roots. If you haven't watched it already, I would definitely recommend that you go watch Simplifying Square Roots, my first video, because I teach you a quick and easy method for simplifying these things here. These things like square root of 27, square root of 75, because we're going to use that whenever we talk about this kind of a problem. One more note, and this, I don't know if I should do this or not, because I'm not a salesman or anything, I'm just a high school teacher, but hey, you know what, if you're in the United States and you take the ACT and you've got to do problems involving square roots, there's a calculator, if it says multi-view at the top, this calculator is the only calculator that I'm aware of. I know there's probably others out there, but this is the only one that I'm aware of that actually does this kind of a problem for you, where I can type in the square root of 50 plus the square root of 18, and I can actually get a simplified radical answer. It's going to be 8 square roots of 2. That's what we're going to get at the end of this problem. But let me show you how to do it by hand. Okay, enough of the sales pitch, I guess, about Texas Instruments. Good for them. The square root of 50, I need to be able to simplify first. So I go back to my list of perfect squares. So I'm going to go back to this list that I have from my first video. I'm going to look for the biggest perfect square that comes out of 50. And that, in this case, would be 25. 25 is the biggest perfect square that goes into 50. So I'm going to rewrite this then. Instead of the 50, I'm going to say that that's 25 times 2. I'm going to do the same thing with 18. The biggest perfect square that goes into 18 is going to be 9. So instead of the square root of 18, I'm going to write 18 as 9 times 2. Now I'm ready to roll. With that in mind, I'm going to break up right here. Instead of the square root of 25 times 2, I'm going to say that that's the square root of 25 times the square root of 2. And if that doesn't make sense, go watch that first video, like I said. The reason that that's important that I have the 25, a perfect square in there, is because I know that. Square root of 25 is just 5. Okay, sorry about our bell there. This is the third time I've tried to make a video. I keep getting interrupted. So I'm going to keep going. Okay? This is 5 times the square root of 2. That's the square root of 50 simplified. Now let's go and work with the 18. Instead of having the square root of 9 times 2, I'm going to write that as the square root of 9 times the square root of 2. I can do that. And the reason that's important that I pulled a perfect square out is because I know the square root of 9. That's 3. So I really have 3 square roots of 2 over here. And if I have 5 square roots of 2 on the left and 3 square roots of 2 over here, that means I have a grand total of 8 square roots of 2. You just add 5 and 3. And that's my answer to this problem. Okay, let's try another one. Let's try an addition problem, square root of 63 and the square root of 112. So once again, I go to my list of perfect squares. I'm looking for the biggest number that goes down to 63 evenly. So start here. 64 doesn't, 49 doesn't, nope, nope, nope. There we go, 9 does. 9 times 7 is 63. So I'm going to call this, instead of 63, I'm going to call it 9 times 7. And I'm going to break that into square root of 9 times the square root of 7. And the reason that's important is because I know the square root of 9, that's 3. So I really have 3 square roots of 7 over here on the left. Now let's go do the same thing with the 112. Okay, now, if I go through my list, and I look through and try to find what's the biggest number that goes into 112, I go through the list, not 100, not 81, not 64, not nope, 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 nope. I'm doing division every time. You would find out that 16 goes into it, though. 16 times 7 is 112. That takes a little division in order to get it. And it looks like we got, that might take a few tries to get that answer. So I break that up into 2 square roots. That's the square root of 16 times the square root of 7. And the reason that's important is because I know the square root of 16, that's 4. So I really have 4 square roots of 7 over here. So if I have 3 square roots of 7 on this side, and I have 4 square roots of 7 on this side, that means I have a grand total of 7 square roots of 7. That's the answer. Now if I can do that with subtraction, or with addition, excuse me, I can do that with subtraction as well. Let's do 2 more problems. Okay? The only difference is, if this becomes a minus sign at the end, I subtract 5 from 3. If this is a minus sign, I would end up with 5 square roots of 2 minus 3 square roots of 2. 5 minus 3 would give me 2 square roots of 2 instead. That's the one difference. So let's try it with a couple problems over here. 75, the biggest perfect square that goes into that is 25. So that's 25 times 3. The square root of 25 times the square root of 3 would be written as 2 separate square roots. That's important because I know that. That's 5. I have 5 square roots of 3. Now, let's go through and find what the square root of 12 is. The biggest perfect square that goes into 12 would not be 9, it would be 4. 4 times 3 is 12. So I write this as, instead of 12, I write it as 4 times 3. That's the square root of 4 times the square root of 3. And that's important because I know this one. This is 2. So if I take 5 square roots of 3 and I take 2 of those square roots of 3 away, I'm left with 3 square roots of 3. Last problem. Same idea, just bigger numbers. The biggest perfect square that goes into 162, I'll save you the time. You'd have to go all the way up to numbers that go to 162. So I need to add 11 squared and 12 squared and 13 squared, so on and so forth. The biggest ones end up being 81. It's 81 times 2. So I would go through the list and I'd work backwards. I'd find out that 81 goes into 162 evenly. So I'm going to write this. That's 81 times 2, which is important because that's the square root of 81 times the square root of 2, which is important because this is 9. That's 9 square roots of 2 on the left. On the right, the square root of 32. The biggest square that goes into 32 is going to be 25. 16 does, though. 16 times 2 is 32. So I rewrite it the square root of 16 times 2. I break them up into separate square roots. And that's important that I had the 16 in there because that's 4. 4 square roots of 2. If I have 9 square roots of 2 and I take 4 of them away, I have 5 square roots of 2 left. And that's how you add and subtract square roots. Hopefully that makes sense. I'm going to make one more video here in just a minute, and it's going to talk about rationalizing the denominator.